With section 6, working with rational expressions. We'll be simplifying these, multiplying, dividing, adding, subtracting. When it's a fraction, this can get a little tricky. Simplifying complex rational expressions, seeing a little bit of calculus. I don't think we rationalize any numerators here, but let's give it a shot. We'll also be taking a look at numbers that are going to be excluded from the domain, which, as a refresher, is the set of x values that are on the graph. Meaning if we plug it in, we get some output, which ends up in the range, but these are going to be sets of x values that are on the line or have a valid outcome. Previously, we saw diamond method. Here we have a rational expression on the top with y squared minus 10y plus 25, then dividing by y squared minus 25. The top portion, you should be able to factor this out without too much difficulty. We have a product of positive 25. We have a sum of negative 10. The only two numbers that work here, well, let's think about it. We have a product that's positive, but the sum's negative. And the only way that happens is if both terms are negative. Thinking factors of 25, we have 1 and 25. We also have 5 and 5. 5 and 5 is going to be the one that works best. So, at least for the top portion here, we can rewrite that as y minus 5, so y minus 5. If you really want to take a step further, you could say this is y minus 5 squared, but with problems like these, I try to expand the rational expression as much as possible. I'll factor it as much as I can to make sure that I know what expressions are in the numerator or denominator, and then I start to simplify towards the end. But for the most part here, your instinct should be saying that we need a factor at first. Because if you just focus on this and you think, well, I have y squared, I need to deduct this too, it's not going to look that way. And we'll soon see how this is evaluated. For the term in the bottom, that should be familiar. I'll give you a moment to try and think out what that would factor to. Since there are only two terms, this is a pattern that we see in factoring. Hopefully you're noticing that this is a difference of squares. So we know that 25 is a perfect square with 5 and 5. We need y plus 5 along with y minus 5. Although we don't focus too much on the domain in this section, we could say that the domain would consist of values that are not positive 5 or negative 5. And hopefully you're seeing that we can cancel out y minus 5 and y minus 5, leaving us with only y minus 5 over y plus 5 as our final answer. So the domain portion is a little extra, but the main simplified version you would want for this is y minus 5 dividing by y plus 5. For 2, it has a lot going on, multiplying or dividing as indicated. You can pick your poison on where you want to start, but you should definitely notice that there's a lot of factoring that can be done. So we see a difference of squares here. We see a few trinomials that will factor. I'll focus first on the first two rational expressions. So with x squared minus 9, we can factor that. Square root of 9 is 3, so this can be x plus 3, x minus 3. We have a product of negative 18, sum of 7. So this should be x plus 9, x minus 2. This is then multiplying with x squared minus x minus 2, which is really simplified to x minus 2 and x plus 1. Factoring this, product of 12, sum of 7, x plus 3, multiplying with x plus 4. If you want to start to cancel out x plus 3, go for it, but I'll take this further. Since we're dividing with a rational expression, this should sound familiar, where we just switch to multiplication and rewrite it with the denominator now as the numerator. So x squared plus 13x plus 36 over x squared minus 3x. So notice we were dividing this final fraction. We use the reciprocal, and we then switch to multiplication. So if we continue to factor out this portion, I'm going to kind of bunch everything up onto one fraction now. So I have x minus 3, x plus 3. We're multiplying, so this is fair game to just write this all on the same line. We're now multiplying this with the factored form of x squared plus 13x plus 36. I know that this is divisible by 4 and 9, and 2 and 18. I'm going to go with 4 and 9. Of course, if you have any questions on how this is factored, please let me know in class or shoot me an email. We have the denominator, x plus 9, x minus 2, x plus 3, x plus 4. X is a common factor with x squared and 3x, so let's take care of that and factor that out. As we see here, there are a lot of binomials, and this should look intimidating, but now at this point we can cancel a lot. So if we notice closely, we have an x plus 9 in the numerator and the denominator, so we can cancel that. We also have x plus 4, numerator in the denominator, cancel that. X minus 2 there and there, x plus 3 here and here. So all we really have left in our numerator is the following. We have x minus 3, x plus 1, we have that x, and also x minus 3. Now we can cancel that too. So really all we need is x plus 1 over x. As you see with this problem, there's a lot of factoring. There's a lot that needs to be registered before you take it further. But really what it comes down to is factoring. And as we see here, most of this was just factoring trinomials. You had a greatest common factor to factor out here, and you also had a difference of squares eventually. We see a lot of cancellation, which is good. That's what you want. Chances are most of the answers are going to be simple. Seen here, x plus 1 over x isn't anything too bad. So be careful with these problems. If you're really curious about the domain on this one, it would be what? X cannot be equal to -9, 2, -3, -4, 0 because of this denominator, also +3, also -4, -9, but we already have -4, so definitely -9. And we already have that, okay. So that's our domain also. Fun stuff. Check part 2 for an additional tricky problem.